In a significant development shaking the automotive industry, recent investigations and recalls have spotlighted severe engine failure problems plaguing certain Toyota vehicles, particularly those featuring the innovative twin-turbocharged 3.4-liter V6 engine. Officially designated as the V35A, this powertrain, introduced to enhance performance and efficiency in full-size trucks and luxury sport utility vehicles, has instead become a source of widespread concern among owners and experts alike. The issues primarily affect the Toyota Tundra pickup truck models from the years 2022 through 2024, as well as select Lexus models including the Lexus LX from 2022 to 2024 and the Lexus GX from 2024. Initially celebrated for its robust output of up to 437 horsepower and 583 pound-feet of torque in non-hybrid configurations, the V35A engine was designed to replace the venerable 5.7-liter V8, promising better fuel economy without sacrificing power. However, manufacturing flaws have led to premature and catastrophic breakdowns, prompting Toyota Motor Corporation to acknowledge the defects publicly and initiate multiple safety campaigns. These failures not only pose risks to vehicle reliability, but also raise questions about road safety, as affected engines can suddenly lose power during operation, potentially leading to hazardous situations on highways or in traffic. The root cause of these engine failures, as identified by Toyota engineers and confirmed through extensive diagnostic teardowns, traces back to residual machining debris generated during the production process at Toyota's manufacturing facilities. This debris, consisting of minute metal particles and shavings, was not adequately removed from the engine blocks before assembly. Over time, as the engine operates under normal driving conditions, these contaminants can dislodge and migrate to critical internal components, most notably the main crankshaft bearings. These bearings are essential for supporting the crankshaft, which converts the piston's linear motion into rotational force to propel the vehicle. When debris adheres to or embeds in the bearing surfaces, it disrupts the thin film of lubricating oil that prevents metal-to-metal contact. This leads to accelerated wear, scoring, and eventual failure of the bearings. In severe cases, a failed bearing can spin within its housing, generating excessive friction and heat, which warps surrounding parts and causes the engine to seize entirely. Owners have reported initial symptoms such as unusual knocking noises emanating from the engine bay, irregular vibrations during acceleration, rough idling that feels like the vehicle is misfiring, or even a complete inability to start the engine after prolonged use. More alarmingly, some drivers have experienced a sudden loss of motive power while traveling at highway speeds, which could result in loss of control or rear-end collisions if not addressed promptly. Toyota's response to this escalating crisis began with an initial safety recall announced in the middle of 2024 targeting approximately 102,000 vehicles, predominantly from the 2022 and 2023 model years of the Tundra and Lexus LX. At that time, the company attributed the problem solely to the aforementioned machining debris and offered free engine replacements as the remedy, performed at authorized dealerships. However, as warranty claims continue to mount, reaching into the thousands according to documents filed with the National Highway Traffic Safety Administration, it became evident that the issue was more pervasive than initially anticipated. Reports from owners indicated that even the replacement engines, which were supposed to incorporate improved cleaning processes during manufacturing, were exhibiting similar failures after only a few thousand miles of operation. This suggested potential underlying design vulnerabilities in the V35A architecture, such as high internal pressures from the twin turbochargers exacerbating the debris-related wear or inadequate oil flow to the bearings under certain load conditions. Independent mechanics and automotive analysts have speculated that the engine's compact design, aimed at fitting into modern vehicle chassis while meeting stringent emission standards, might contribute to hotter operating temperatures that accelerate degradation when combined with any contaminants. Building on these findings, Toyota expanded its recall efforts with a second major announcement on November 6, 2025, adding roughly 127,000 more vehicles to the campaign. This extension included additional 2023 and 2024 Tundra models as well as incorporating the 2024 Lexus GX 550 for the first time, bringing the total number of affected vehicles in North America to over 229,000. The recall specifically targets non-hybrid variants equipped with the conventional gasoline V35A engine, excluding the iForce Max hybrid versions that pair the engine with electric motors for enhanced durability. According to official filings with the National Highway Traffic Safety Administration, the expanded recall was prompted by an analysis of over 3,000 warranty claims and field reports detailing engine failures consistent with bearing damage. Toyota has committed to notifying affected owners via mailed letters, with the process beginning in early January 2026, urging them to schedule inspections at no cost. For vehicles confirmed to have the defect, the remedy involves a comprehensive engine replacement, though the company has not yet detailed whether further modifications such as enhanced oil filtration systems or redesigned bearings will be implemented in the new units to prevent recurrence. The fallout from these engine issues has extended beyond mere mechanical repairs, sparking broader scrutiny from regulatory bodies, consumer advocacy groups, and the automotive press. The National Highway Traffic Safety Administration has opened investigations into the effectiveness of Toyota's initial fixes, reviewing data on post-replacement failures to determine if additional actions are warranted. Class action lawsuits have been filed in several United States districts with plaintiffs alleging that Toyota knew about the potential for debris contamination during early production but failed to implement sufficient quality controls, leading to diminished vehicle values and unexpected repair costs for owners outside of warranty coverage. Online forums, social media platforms, and owner communities such as those on Reddit and Facebook groups dedicated to Toyota trucks are rife with personal accounts of frustration. One Tundra owner from Texas described hearing a death rattle from his engine after just 15,000 miles, while a Lexus LX driver in California reported being stranded on a remote highway when his vehicle suddenly stalled. These anecdotes highlight the emotional and financial toll, with some owners facing downtime of weeks or months while awaiting parts, and others opting to trade in their vehicles at a loss to avoid future risks. This saga has notably tarnished Toyota's long-standing reputation for unparalleled reliability and longevity, a hallmark that has defined the brand for decades and helped it dominate segments like full-size pickups and luxury sport utility vehicles. Competitors such as Ford with its EcoBoost engines and Chevrolet with the Silverado's Duramax diesels have seized the opportunity to emphasize their own powertrain durability in marketing campaigns. Analysts from firms like Kelley Blue Book and Edmunds have noted a dip in resale values for affected models, estimating losses of up to 10% compared to pre-recall figures. Moreover, the issues have prompted Toyota to reassess its supply chain and assembly protocols at plants in Alabama and Japan, where the V35A engines are produced. Implementing advanced cleaning technologies like ultrasonic baths and enhanced visual inspections to mitigate future debris problems. Industry experts suggest that while Toyota's proactive recall approach demonstrates corporate responsibility, the persistence of failures in replacement engines could indicate a need for a fundamental redesign, potentially delaying new model introductions or increasing production costs. For current owners of the implicated vehicles, vigilance is key to avoiding potential disasters. Toyota recommends monitoring for any unusual engine sounds, such as persistent knocking or tapping that worsens with acceleration, and immediately reducing speed and pulling over if power loss occurs. Drivers are advised to contact their nearest Toyota or Lexus dealership for a diagnostic check, which may include oil analysis or borescope inspections to detect early signs of bearing wear. In the interim, some mechanics suggest more frequent oil changes, every 3,000 miles instead of the factory recommended 5,000, to help flush out any lingering contaminants. As the situation evolves with possible further updates from the National Highway Traffic Safety Administration or additional recalls in 2026. Affected consumers are encouraged to stay informed through official channels like Toyota's recall website or the administration's safercar.gov portal. This ongoing engine crisis serves as a stark reminder that even industry leaders like Toyota are not immune to manufacturing challenges in the pursuit of advanced technology. In a separate but noteworthy development that has captured the attention of Toyota enthusiasts and mechanics, a detailed video examination has brought to light a concerning case of internal engine damage in the naturally aspirated 3.5-liter V6 engine, officially designated as the 2GRFKS, installed in certain 2016 to 2017 Toyota Tacoma pickup trucks. This engine, which debuted as part of the third-generation Tacoma redesign to deliver a blend of strong performance, improved fuel efficiency, and modern features like direct and port fuel injection, along with variable valve timing, intelligent wide, produces approximately 278 horsepower and 265 pound-feet of torque. It was engineered to succeed the older 2.7-liter four-cylinder and 4.0-liter V6 options, aiming to provide smoother power delivery for everyday driving and light towing duties. However, this particular instance, involving a vehicle with around 69,000 miles, illustrates how even Toyota's typically durable powertrains can encounter premature wear, leading to progressive deterioration that ultimately necessitates a full engine replacement. The teardown, performed by experienced automotive technicians, revealed a slow but steady self-destruction process within the engine's internals, highlighting vulnerabilities that appear more pronounced in these early production years of the 2GR FKS family. Symptoms in this documented case began with increasingly noticeable knocking noises from the engine bay, a sound often described as a deep, rhythmic thud that grows louder under load or during acceleration, and signals serious mechanical distress. Owners of affected 2016 and 2017 Tacomas have reported similar progressive issues where the knocking starts intermittently before becoming constant, accompanied by rough idling, reduced power output vibrations felt through the steering wheel and floorboard, and in some instances diagnostic trouble codes related to misfires or cylinder imbalances. In this specific teardown, the engine was removed from the vehicle after the owner experienced these escalating symptoms, prompting a complete disassembly to uncover the root causes. Technicians noted visible oil staining around the timing cover, a relatively common leak point in the 2GR FKS engines that can contribute to lower oil levels if not monitored. More critically, upon opening the block, severe scoring and physical damage appeared on the piston skirts, particularly in the middle cylinders, with evidence of excessive piston-to-cylinder wall clearance that allowed the pistons to slap against the cylinder bores during operation. This clearance issue, which manifests as the characteristic loud knocking, stems from accelerated wear patterns where the pistons rock excessively within the cylinders, leading to scoring on both the piston skirts and the cylinder walls themselves. The teardown further exposed seized oil control rings on the affected pistons, preventing proper oil scraping and drainage, which exacerbated lubrication problems and contributed to the metal-on-metal contact. Experts analyzing the failure have pointed to a potential design flaw in the early piston oil control hole configuration, which may have allowed carbon buildup or inadequate oil flow to keep the rings mobile, especially under the heat and stress of typical Tacoma usage, such as off-road driving, towing, or stop-and-go traffic. Notably, the crankshaft, connecting rods, and main bearings exhibited minimal to no unusual wear, indicating that the damage was localized primarily to the piston and cylinder interface rather than a widespread bottom-end failure. Toyota addressed similar concerns in later production runs by revising the piston oil control hole design starting around 2018. Suggesting that these early 2016 and 2017 models may represent a transitional period where manufacturing tolerances or material specifications were not yet fully optimized for long-term durability in all operating conditions. While this case appears more isolated compared to widespread manufacturing debris issues in other Toyota engines, it has sparked significant discussion within owner communities, forums like Tacoma World and Reddit's Toyota Tacoma subreddit, and among independent mechanics. Reports indicate that 2016 and 2017 Tacomas have been flagged as having higher incidences of such premature internal wear, with some owners experiencing complete engine failures requiring replacement under warranty or at substantial out-of-pocket cost if beyond coverage periods. In contrast, many 2GR FKS engines in later years or different applications, such as the Camry, Highlander, or post-2017 Tacomas, have proven far more robust, often surpassing 200,000 miles with routine maintenance. Other common complaints with the early 2GR FKS include timing cover oil leaks, occasional high-pressure fuel pump concerns, and valve train noises that Toyota has sometimes attributed to normal characteristics or addressed via technical service bulletins, such as those for vacuum pump knocking that mimics rod knock. These early-year teething problems have led some analysts to recommend caution when purchasing used 2016 or 2017 Tacomas, advising thorough pre-purchase inspections including borescope checks of the cylinder walls through the spark plug holes to detect early scoring. This incident underscores a broader theme in the automotive world. Even engines from a brand renowned for exceptional longevity can face specific vulnerabilities during initial production phases as manufacturers refine designs to meet evolving emissions, performance, and efficiency standards. The naturally aspirated 2GR FKS, while generally praised for its smooth operation and adequate power in the mid-size truck segment, lacks the forced induction complexities of newer turbocharged V6s, but still demands vigilant maintenance, including frequent oil changes with high-quality synthetic lubricants every 3,000 to 5,000 miles, prompt attention to any leaks and monitoring for unusual noises. Owners of 2016 to 2017 Tacomas experiencing knocking or related symptoms are strongly encouraged to have their vehicles inspected by a Toyota dealership or qualified independent shop equipped with diagnostic tools and borescopes. In cases where damage is confirmed, Toyota has historically provided engine replacements under powertrain warranty when applicable, though coverage varies by mileage and date. As more high-mileage examples accumulate and additional teardowns emerge, the long-term picture of the 2GR-FKS continues to evolve, reminding drivers that proactive care remains essential to maximizing the lifespan of even the most respected powertrains. This case, while not indicative of a universal epidemic, serves as a cautionary example that Toyota's reputation for bulletproof reliability is built on continuous improvement rather than infallibility in every iteration.